Welcome to one of the most hated topic tutorial, back titration. Before we dive into this calculation, let's make a little overview of the type of exam questions that you might get. So back titrations are type of titrations where instead of directly measuring the concentration of an unknown compound, the concentration is measured by finding out the excess amount of unknown concentration. And this is often used for calculation finding the percentage purity or the identity of element or the percentage by mass. One of the most common type is acid and base back titration. And this is used when an analyte is an insoluble base or an acid. So it can be used to determine the amount of an insoluble base like calcium carbonate by reacting it with a known excess of acid, then titrating the remaining acid with a standard base. The second example would be redox back titration. This is when we have a direct redox titration and it's not feasible, such as when the reaction is too slow. For example, a back titration might be used to determine the concentration of a reducing agent by reacting it with an excess of an oxidizing agent and then titrating the unreacted oxidizing agent. What all of these have in common is that we have an initial amount and an excess amount that we need to calculate. So considering this initial and this excess, which will allow us to find the amount reacted using the mole ratio and subtracting these two values, let's try to approach this calculation. Now pause the video and make sure you fully read this question and try to understand what is happening. Now that you read it, you might be even more confused than before, but play and stay with me because I'm going to help you working this out. The first and most important thing to do in back titrations is that you understand the equations and read the chemical reactions that are taking place. So we can see from reading this that we have a phosphorus pentachloride, and in this case is reacted with water to form phosphoric acid and hydrochloric acid. We can already write down the first equation. So we have the first balance reaction reaching out. Let's read the question again to find the second reaction, because with back titration, we're always going to have two chemical reactions. We have the excess of sodium hydroxide that was titrated against hydrochloric acid. This is the second chemical reaction taking place, but in between there is another one because we have a mixture of acid that is added to sodium hydroxide. So notice how we have three chemical equations that are taking place, three chemical reactions. So from the green reaction, we have this light blue reaction. So the acids, which acids? The phosphoric and the hydrochloric acid react with the sodium hydroxide. But this sodium hydroxide is added in excess. This is because in the third, and that's the titration, we'll be able to identify how much of this hydroxide has reacted with the acid. So what is extremely important in back titrations is that you understand the relationship between each of these reactions. Make sure you pause the video if you still need to process this, but this is the first and most important step. Now that we understood what reactions are taking place, we can start with the calculations and remember, it's back. Back means that we start at the end and we work our way up. So what can we find from the latest reaction? We can find how much of the hydrochloric acid, so the titrant, reacted with the hydroxide. So let's do that. Remember, writing labels is extremely important. So we have the titrant, HCl. And that is equal 0.5, which is our concentration, times the volume, which is 0.151. This is the volume of the titration. This gives us an amount of moles of 0.00755 moles. Okay. This means that, because we know that the ratio is 1:1 between the hydroxide and the hydrochloric acids, this is the same as the amount of the moles of the hydroxide in excess. Where does this excess come from? It comes from the second reaction. Now, notice that there has been a dilution. The question to always ask yourself is in which volume, because this sodium hydroxide is in the volume titrated, which is in 25 centimeters cube. So we work backwards and we look, okay, what was the volume before? 500. So the moles of hydroxide in 500 centimeters cube, we looked at the dilution factor, 500 to 25, it's times by 20. So we will have the moles times by 20 because that's the dilution factor, and this gives us 0.151 moles of sodium hydroxide. Now, what do we know in the second reaction? Let's put some numbers. 1, 2, 3. In reaction number 2, we know the initial amount of hydroxide. So let's call it initial. And that was equal to 2.4, which is the concentration, times by 0.3, which is its volume, giving us 0.72 moles. We have an initial and we have an excess. So what can we find? We can find how much it reacted. And the amount reacted is always found by subtracting the initial amount minus the amount that was in excess. So this gives us 0.569 moles. And now we need to think about how is the OH minus of the second equation related to the first equation, and this is where reading the question again might be useful. And we see that the mixture of acid was reacted with the sodium hydroxide. This means that we need to figure out how much of the acid that corresponded to and what's the ratio between the acid and the PCl5. If we look at the H plus and the PCl5, we see a ratio 8 to 1. So if the moles of the acid is equal to 0.569, because hydroxide and H plus react 1-to-1 ratio, we need to divide it by 8, and these will be the moles of the PCl5. Now, this is the titrations, and then the steps may change a little bit depending if you have to find like the identity of an atom, and in that case you would calculate the MR, but in the case of finding like a percentage, I would suggest you to work with masses. So let's find the mass of the PCl5, and that it would be equal to the moles, so 0.0711 times by the MR. The MR is 208.5, and this gives us 14.83 grams. To find the percentage purity would be the mass that we found divided by the initial mass, which, if you recall, was 15 grams. All of it times by 100, and this gives us 98.9% pure. So I hope this tutorial helps in understanding the approach of back titrations. The first important thing is the equations, understand the relationship between them, and remember it's back, so we're gonna have to start working from the last equation on the way up. Always have the equations down and always ask yourself in which volume, because dilutions are going to be present.